This is Math 20, section 4.8 on solving percents by using proportions. When we're finished, we'll hopefully be able to calculate some answers to percent problems, use proportions to solve percent application problems, and find and use percents of increase and decrease. When we use a percent, we're actually using it in the sense of making a comparison. And it's the percent itself is the number that's in the percent compared to 100. So if we had 30%, as we previously explained when we were first talking about percents, that's a 30 out of 100. When percents are applied to some kind of a problem or real life situation, this percent is then equated to another amount of something compared to a base of that same thing. Let me explain what that means, because by itself that just doesn't make any sense at all. For example, if we were out shopping and there was a sale going on and it said it was a 50% off sale, and we picked up an item that was $60, then we would expect to pay $30. So this is the percent. This is the amount of reduction for every $50 for every $100 is what we're getting off. And if the sale item only cost $60, then we would essentially be paying just half of that, which would be $30. So the 50% part is 50 out of 100 is equal to the amount that we're paying in this case, or the amount of deduction, because the 50% is 50% on and 50% off, out of a starting point of $60. This is representative of part to whole. Now, if it was I need to point out something to you. If it was a 30% off sale, we would this part to whole would be the amount of discount compared to the original price. The flip side of that is if you're getting a 30% discount, well, how much are you paying? Well, you're paying 70%. So the part to whole in that case would be 70 to 100, or the amount that you're paying to the base. In this particular example, using the 50%, we can change the 50% to a fraction, and it looks like that. And this is our part. This is the part to the base, the original value, part to base. And this number up here represents the percent. This part down here, this is fraction over here. It's always going to be something over 100, because that's what a percent is. How much out of 100? And the problems that we're going to be working that concern percents, we're going to basically be missing one of these components in the proportion. And because we're using percents, this part of the proportion where it's something over 100, that's always going to stay in place. So the part that remains is going to be this guy, the part and the base, and the number that goes in the percent. So this is our general format. This is not going to change. The value of the percent over 100, and this is the part that we're talking about, and this is the base that we're talking about. So, and that's explained down here. So this is the format that we're going to try to apply. Think of it as a formula almost. Okay, so we've got 3 different kinds of problems here, and I want you to follow this format. This is like a template for you to follow. This is going to work all the time. So it says 9 is what percent of 45? So the first thing that I can do is I can set it up like this. Something over 100. Now, I don't know the percent. That's the question. What's the percent? So I know that that's my x. And this is going to be part to base. Well, which one of these guys is the part? Well, 9 is the part. 9 is what percent, what part of this base? And that's my proportion. And what we would do from here is just simply use our cross multiplication. So I'm going to call it 45x is equal to 9 times 100. 45x is equal to 900. and x turns out to be 20. So the answer in this case is 20%. X 20 over 100 is 20%. So if I'm looking for the percent, this is the answer. And this is the algorithm that I'm going to follow to get that answer. Let's take a look at the next one. Again, we're going to set it up. Something over 100 is going to be equal to some part over a base. Well, this time I know the percent, so I'm going to put 15 in here. 15% of something is what? This guy's my base. This is the part, and I don't know that. I want to know what part of 435 is 15%. So my 435 goes down here. And again, I'm going to go ahead and solve that over here. So I have 100x is equal to 15 times 435. And I've got 100x is equal to, I can't do that one in my head, so it's 15 times 435. And I get 65.25 out of that in my calculator. And x is equal to, and if I divide that by 100, I end up with 65.25. Now remember, this is not the percent. I was given the percent. This is the part. This is the part. So that would be the answer to this proportion. And finally, the last one, 42 is 5% of what? Again, it's always going to be something over 100 is equal to, well, 42 is the 5%. 42 is the part, and I'm missing the base. And one more time, I'm going to go ahead and use cross multiplication. I have enough room, I can do it right here. 5x is equal to 42 times 100. 5x is equal to 4200. And x is equal to 840. 840. And that would be my base. Now, one of the difficult parts about setting this up, though, and it's not that difficult, but I've got a little trick for you. This part is always going to be the same. This is the percent half of the proportion. And it's a matter of who goes where over here. And if we could get that nailed down, we would be home free. Well, there's a little trick that says that the right-hand side is always is over of. Is over of. Well, what am I talking about, is over of? It says 9 is. That's what goes on top. Of 45. That's what goes on the bottom. Now let's see if it works on the next one. Is what? That's what I don't know. So is the x goes on top. Of 35 goes on the bottom. And let's try this one. Is over of. Is 42 is. That goes on top. Remember, now you might say, well, the 5% is over by the is. No. The 5% is taken. You can't touch him. And then of what? And there's my variable. So if you're not sure quite where to put the values, use this little trick, is over of, and it works great every single time. An application problem that we can put into effect here is, let's see, you scored 78% on your test, and you received, or 78 points on your test, and you received a grade of 83%. How many points were possible? Well, I'm going to set up a proportion. Something over 100 equals something over something. This is the part, this is the base. This is what you earn. And well, first of all, I can take the 83 and put it in here. This is what you earn. This is the part that you earned. How many points were possible? What's the base? That's the question here. That's the question. So we've got 83x is equal to 100 times 78. 83x is equal to 7,800. And x is equal to, and I'll have to use my calculator for this, 7,800 divided by 83 equals, and I've got 93.97590. So I think it's safe to say that there were probably 94 points 94 points total on the test. This next part on here pertaining to increases and decreases, I'll be working problems out of your book starting with page 404.